Factor the following expressions. In this exercise, there will be 3 different examples here. In example A, and in fact all of these examples, what we need to do is first check for a greatest common factor. And if you look with these 2 terms right here in A, it looks like both of these terms can be divided by 4, and they can also be divided by x. So when we do this division by 4x is what our greatest common factor is. So I'm going to put that out front here. So this will be 4x. And then when we go back and actually divide this, 12 divided by 4 gives me a 3. Oops. And x squared divided by x gives me an x. In the second term, 8 divided by 4 gives me a 2. And x divided by x leaves me with no x's, so I can just close that off. And this will be the answer for part A. Part B, we need to look for a common factor. We can't divide 9 or 49 by something other than 1 evenly. And we cannot take a common factor of x because the first term has x's, but the second term does not. But we can notice that 9 is a perfect square number, 49 is a perfect square number, x squared is a perfect square. So we can use the difference of squares factoring here. So if you take the square root of 9, you're going to get 3. I'm going to set up 2 sets of parentheses, and we're going to get 3. So I'm going to lead both sets of parentheses with the square root of that 9. The square root of x squared is x, and the square root of 49 is 7. So one of these sets of parentheses will get a plus, the other will get a minus, and that's it. There's your answer for part B. In the third example, I see now that there, first of all, should be an x here at the end. Again, the first thing we need to check for is greatest common factor, kind of like what we did up here in part A. And when you take out the greatest common factor, it's going to look something like this. Here, the least common denominator, or the greatest common factor, is 2x. And when you divide all 3 terms by 2x, the 2x will come out to the front, and then you will have to divide these to get what's on the inside of the set of parentheses here. From here, now that we have a greatest common factor, you still have to check to see if the insides factor. And that's going to determine whether or not we have simplified this or not. So over here in blue, I'm going to write down my AC and my B. So I need 2 numbers that multiply to -6 and add up to 1. And this means the 2 numbers that we're looking for are going to be 3 times -2 and 3 plus -2. So 3 and -2 are the numbers you're going to need for your AC method factoring over here. And when you use the AC method factoring, you will get this answer right here. You still have to keep the greatest common factor as part of your answer, in addition to what you factored over here. Solve the following equation. In this equation, we have -3 times the quantity x minus 2 equals 5 times the quantity x plus 3 plus 7. And the first thing that we need to do, or I guess our goal first, is to make sure that we isolate x on one side, and hopefully we have some number on the other side. But as this equation stands, the x's are trapped inside this set of parentheses. We can get them out of the sets of parentheses if we take the numbers in front and distribute to the sets, to each term inside of the parentheses. When you do that, you will get this. So we have negative 3x plus 6, negative times negative is positive, equals 5x plus 15 plus 7. The next step here is, or the next goal, now that we have the x's in a place where we can move them from one side of the equation to the other, our goal now is to get all of the x's on one side of the equation and all of the numbers on the other side. Even before that, I really want to combine these two numbers right here to get this equation. Now that these two have been combined, we can move the x's to this side, the right side, and the constants to the other side. So it's going to look something like this. You want to add 3x's to both sides, and you want to subtract 22 from both sides. Notice that when you add x's to both sides, you will be adding x's to x's, and you will be subtracting constants from constants. And when you do this, this will simplify to negative 16 equals 8x. And that is because over here on the left side of the equation, the 3x's will reduce away to 0. And on the right side of the equation, the 22 and the negative 22 will also reduce away to 0. Leaving you with 5 plus 3x's is 8x's, and 6 minus 22 is negative 16. The last step here is to divide both sides by 8 to get an answer of x equals negative 2. Solve the following linear inequality. Express your answer in interval notation. So this example will be done similarly to the last example, except it's no longer an equation. We have this inequality symbol here. So again, similarly to the last example, these x's are inside these sets of parentheses. We really want them not to be. We don't want them to be trapped in there. So the first step would be to distribute the numbers outside to the each term inside to get something like this. The next step here would be to move all of the x's to the left side of the inequality. And the reason that it's easier, or the reason why we want the x's on the left side of the inequality, is so that when we get to the final answer, it will be easier to interpret and change over into the interval notation. So with this, I will be subtracting 15 x's from both sides, and I will be adding 6 to both sides. So all of the x's will be on the left side of the inequality, because the 15x's minus the 15x's will reduce to 0. And all of the constants will be on the right side of the inequality, because negative 6 plus 6 is 0. So you'll end up having something like this. The last step here is to divide by negative 12. That's how we isolate the x. And when this happens, we'll get x and 7. But also, since you divide by a negative, the inequality sign changes direction. So that means this inequality sign, since we divided by a negative 12, will change directions. So we read this as x is greater than or equal to 7. What this looks like in interval notation is we want numbers that are bigger than 7. So we will start the interval notation at 7, and numbers that are bigger than 7 go all the way to infinity. Now the ending symbol here on 7 will be a square bracket because of the equal to bar in our inequality. So we solved the linear inequality, and we have our answer in interval notation. Mary is building a garden in her backyard and wants to put up a fence so she can keep out any pests and rodents that may try to eat her vegetables. In order to fit correctly, the length of the garden must be 1 foot less than twice the width. If she purchased 82 feet of fence for the perimeter of her garden, what must the length of the garden be so that she uses all of the fencing? In this example, we have to decode some plain English into mathematics. And before we even do that, I want to define what I'm trying to find. The first thing that I'm trying to find is what must the length of the garden be so she uses all of the fencing. So we're looking for length, so I'm going to call L my length. We also don't know anything about the width, so I'm going to call W my width. And we know that all of the units here are in feet. You can see this here, 1 foot less than twice the width, 82 feet of fencing. Now we can start setting up some equations. We're talking about the perimeter of a rectangle, the distance around that rectangle. And the formula for that is the perimeter is 2 times the length plus 2 times the width. And what's really nice is that we know that the perimeter is supposed to be 82 feet. So we can replace that P with the 82. Next, we can try to decode this up here. This is the length of the garden must be 1 foot less than twice the width. So we know that length equals 1 foot less than twice the width. Remember when you see these words less than up here, this tells you that you're going to be performing a difference or a subtraction, but whatever you're subtracting, this 1 and twice the width, 2 times W, need to switch order, so 2W minus 1. From here, we can take this part of our equation, right? L is equal to 2W minus 1, and we can substitute it right into L for the other equation. So we can get this 82 down here in red, 82 equals 2 times whatever the length is equal to, which is 2W minus 1, plus 2W. So now this is just an equation like we were solving a few examples ago. So we can distribute this 2 here and here to get this equation. We can combine these W's since they're on the same side to get this next equation over here. The next step here, we can add 2 to both sides to get this equation. And finally, we can divide both sides by 6 to tell us that W equals 14. So what were we trying to find? The question is being asked is, what must the length be? What must the length of the garden be so she uses all the fencing? We found the width. So in order for us to find the length, we need to take this answer and come back over here and substitute it back in for W in this equation. And that will give us that the length is 27, and our units are feet, as we mentioned earlier. So the length is 27 feet, and just for good measure, the width is 14 feet.